everyone, I'm Shivan Rajput and welcome to this video on IBM Quantum Experience and Circuit Composer. Here we are going to discuss how we navigate through the dashboard called IBM Quantum Experience and where we can find both Circuit Composer and Qiskit at the same place. So, quantum composer, it's a very easy to understand, and here we can create our own circuit. And again, Qiskit, if for someone who know little bit programming and they know little bit Python, so they can directly use Qiskit, and it does not require any new language learning understanding. So if you know Python, you can get started on Qiskit. Okay. Qiskit is Qiskit is the same place, and on the cloud we can see directly access and can see the hardware, the simulator, and have access to, and can also see the documentation, tutorials, open source, and various other self-learning references materials. And we make use of couple of things, and then we are going to dive into Circuit Composer. So all you need to do is to set up, actually get access to an IBM quantum computer. So log into this portal, and that is quantum computing, quantum-computing.ibm.com. And if you have an IBM ID, you can directly log in, and or else you can log in through Gmail ID, LinkedIn, Facebook, Twitter, and you can use that or sign up in this page. And once you have signed up in this page, you will get access to see all the hardwares, the simulators, composers, and quantum lab, Qiskit, all the way at the same place. Okay, so okay, when you will sign up, you will get to see the screen like this. This is the dashboard when you will sign in. Okay, so this is the kind of dashboard. Dashboard is available in okay, wait, yeah. So dashboard is available in various theme, right? A light theme or the dark theme. You can choose whatever you want. And the side of the screen, on the side of the screen, you can see all the news and the notification from the development team. So any major update that development teams are doing, so all the notification of all the developments happening in the quantum team, you will be updated from here. Now coming to the main part, you can see two buttons there. One is the launch composer and the other is the launch lab. So launch composer is the one where we create a circuit, and it's a circuit composer, and it's a user interface method of creating the circuit. And the second is the launch lab, which is the quantum lab. And we can compute in this in Pythonic way, or you can use it directly from this dashboard on the cloud, and where you can do couple of other things. And so you have all the services available there, and you can directly click on it by view all. Okay, so here you can see different hardware, different services, simulators, so that are available to you. You can click on the system, and you can see that there are different types of hardware available to you. And if you see here, these are all the systems. Okay, these are all the systems, or different types of system available at any given time. And you can see these systems, and all the systems are available since 2016. And you can see there in a different number of systems that are available. And IBM released its first quantum computer on cloud. There have been multiple of quantum computers on cloud, and they have put it on cloud, and which are so that it's openly available for the people to use it. And if you click on the system, Okay, if you here by going there, if you click on your system, here you can see these seven hardware. So these are the so these are the hardwares that are openly available, and all of you will have access to this. And these are mostly of 5 qubits machine, and there is 1 qubit machine as well. And if you go down to all the system, okay, if you go down to all the system, yeah, if you go down to all the system, you can see at any given point you have maximum number of systems. So not maximum number of system, not all, but the maximum number of systems. So at this point of time we have 24 24 quantum computers available. So you can see status here, online, and q paused status here. And that's okay, it's we can open one. It's okay, it's online here. You can see different type of processors, yeah, which is here, like eagle, hummingbird, and all. If you want to learn about this processor, you can click on it and see all the details regarding processor will flash on the screen, and you can read about this processor. And here you can see we came up with this canary processor in 2018, which is up to 16 qubits. And then in 2019 we had a major improvement, where we were able to see move from 16 to 27 qubits. And okay, with the Falcon processor. And then in 2020 they have this hummingbird processor. And in 2020 there are also a couple of improvements over in Falcon processor itself. You can see here, like, okay, so this is also a Falcon processor with 128 quantum volume, and this is a Falcon processor with 64 quantum volume, and this is quantum processor with 32 quantum volume. As we have discussed previously, it's a quantum volume. It does not depend on qubits. Okay, it is, there are several other measurement on which it depends. So it's a metric measure. It's a metric to measure the performance of actual quantum computer. On what is the performance of quantum computer. So yeah. And there are a couple of things we can see by clicking on it. There are also a couple of things you can do here. So click on it. By clicking on it, firstly we can see that all the details, we can see that there is no access to this device. Here you can see, as this is the premier device, as this is the premier system with 65 qubits. And so yeah. Hi, we can notice one thing. Here is 65 qubit with 32 quantum volume. And we can also see Falcon with 65 qubits and 32 quantum volume here, 32 quantum volume. So our Falcon with the 60 here, 60, yeah, Falcon with 27 qubits and 64 quantum volume. So this is quantum volume is not first dependent on the number of qubits. There was a study in University of Tokyo, where they actually showed that they did not increase the number of qubits, but they could decrease the error 10 times. So 10 times, then quantum volume increases 5,000 times. So this is one of the important thing there. There are several other things as well. It's not only depend on quantum. It's not only depend on yeah, it's not only depend on, okay, first, sorry, yeah, given you can see There are several other things as well. It's not only depend on number of qubits or error. There are several things like coherence and spectator errors, coupling, map, circuit optimization, and all. There are several other things. It's not necessary that it or only depend on one thing. It's depend on several other things. So so as we move down, we can see the C naught error. We can see the ratio, the range of C naught error from a certain point to certain point, and it will give you where is the average C naught error, average C naught error and a line for this particular machine, and what is the average okay, what is the average T1 and T2 time, or the coherence, and how long the qubits stay in this useful state, or in the state of superposition, because that is how long you can do your computation, and what are the bases, basic gates that are used to build this network. And you see the topology here, you see the topology here, here, like the way qubits are connected there, and there are different views like graph view and the table view. In this table view you will get all the information regarding all the qubits. Okay, so the second point here, okay, we can move back. So the second point here is the simulator. So why they are important? So important, the hardware that is available today is still noisy. So there are some noise in the results and the measurements that are actually that we finally being able to do. So these are the simulators. You can see simulators in just creating your circuits, and it's not just we can create our circuit and getting the output, but also on noise modeling. Then you can actually say that actually say that in a noisy environment. Okay, so this is the quasm simulator, where stand for quantum assembly language. Okay, and this is 32 qubit machine, and it's a general context aware machine, and it is also capable of doing noise modeling as well. And here you can see the 5000 qubit system machine. So this is like, we can also notice that in the real hardware we can still see only 65 qubit machine, but in the simulator we have reached up to 5000 qubits. It's a very efficient, it's very efficient, a Clifford simulator, and it's very efficient. It can also simulate the noise evolutions, and here we can see MPS simulator type matrix product state. And this is the tensor network simulator, and that has metric product representation for the state. And if you go here, in the second tab, you can see all the service tutorials. You will get all the self-learning resources here. So yeah, you can also get all the you can scroll it down and get all the study references materials right there, and all the things are available right there. To learn more about system, you can directly click here and get into the deeper knowledge. And to learn more about simulator, you can directly click on the link and get more information about it. And this is this only information I want to share, how to navigate the system, and this dashboard. And in the next video I will share how to I will you know share how to actually use Composer Lab. Thank you.